Hey Julian, think fast!
Ah! Hi, quick thinkers and slowpokes. It's Julian for DNews. Tim Welsh, a professor of kinesiology at the University of Toronto, recently wrote an article asking, what is the speed of thought? It's a great question with a lot of different answers because thoughts can be huge, complex puzzles or simple reflexes. They can originate internally or from external stimuli, and different people can have the same thought at different speeds. We thought we'd offer our own answer, and to give us somewhere to start, let's talk about the basic unit of a thought. A thought can be billions of neurons interacting with each other at once, swapping chemicals between them to communicate. So it could be said that the most basic unit of thought is a neuron firing. Neurons in your brain consist of cell bodies with dendrites branching out from it, as well as an axon that splits several times at the end. People know that neurons send electrical impulses, but it's not like the electricity in your house that works by passing freely moving electrons, so it's not as instantaneous. Instead, neurons swap ions of different charges across the membrane of the axon. By swapping them at the start of the axon by the cell body, it starts a chain reaction down its length, like a row of people doing the wave. When the signal gets to the end of the axon, the synaptic bundle will release neurotransmitters across the synaptic cleft, which is the tiny space between the end of one neuron and the beginning of the next. The neurotransmitters float to the next neuron's dendrites, and they tell the next neuron how to fire. So the total time it takes a cell to send an impulse down its axon and then diffuse a neurotransmitter across the synapse is our most basic unit. And of course, this being the brain we're talking about, it gets even more complicated. Because axons can either belong to gray matter or white matter. 40% of your brain's volume is gray matter. It's what you use for sensory perception, speech, memory, emotions, and decision making. It's dense with cell bodies, and the axons are short and don't have a fatty protein called myelin surrounding them. White matter, on the other hand, doesn't do the thought processing, but is vital for connecting different areas of gray matter because it has that myelin sheath. That sheath is like the difference between a fiber optic cable and a 56K modem. Without it, gray matter sends its electrical pulses at 0.5 to 10 meters per second. With it, white matter's action potential can travel up to 150 meters per second. It needs that speed because white matter axons in a man in his 20s can total over 176,000 kilometers. The axon in white matter can be up to a meter long, which is good because that means fewer synapses, slowing the signal down. A synapse is a gap between neurons of only 20 nanometers. Some transmissions across the synapse can be quick. If the neurotransmitter opens up the ion channels right away, the whole process can take just half a millisecond. Most receptors, however, use the neurotransmitter to release another molecule, and that secondary messenger opens up the ion channels. That can delay the signal anywhere from 30 milliseconds to a full second. So, between axon length, axon type, and neurotransmitter used, there's a lot of variability in the speed an individual neuron can send a message. Now, consider that a single neuron can have links with thousands of other neurons, meaning your brain can have hundreds of trillions of synapses between its 86 billion neurons. Plus, there are different kinds of thought, like reflexes fast-tracked to the spinal cord, or complex decisions that use billions of neurons across your brain. All of these variables mean thoughts can be had and carried out at vastly different speeds. It's why some thoughts can be nearly instantaneous, like a sprinter starting to move only 150 milliseconds after a starter's pistol, while others take much longer, like deciding whether or not you should tell your crush how you feel. It is possible to think faster, though. Reactions can become reflexes with practice, taking neurons and distance a signal has to travel out of the equation to speed up a thought. Or complex decisions can be made quicker with practice, too. Making different parts of your brain communicate by learning and considering new information can improve the structural integrity of the white matter used, letting it send signals faster, making you better at processing information. It's another great reason to keep coming back for more DNews. I know, shameless plug. You probably have about 86 billion neurons rolling around up there, and you may think you only use 10% of them. You don't. I hate that factoid. Anthony Carboni agrees, and here's the video with the truth.
It is crazy false. There is not a part of your brain that you do not use. There is no dormant part with psychic abilities or the potential to instantly memorize anything you see hidden behind some cranial roadblock up there.
What are your thoughts on thoughts? Are you quick at learning and thinking, or do you need more practice? Let us know in the comments or Facebook or Twitter. Subscribe for more brain food, and I'll see you next time on DNews.